like, I think it's like this, but that's the total wrong way for me to be looking. I think that's my good side right there. Like when I look this way, not as good. So, um, the last time I talked to you guys, we were doing, gosh, I don't even remember what we were doing. It feels like last week was forever ago. Um, but we've been dealing with linear equations up to this point, right? We were graphing them and we were putting them in different forms and we were writing equations. Like we figured out how to take 2 points or anywhere from 2 points on and write the equation of a line. And today we're moving into what we call systems of equations, which is more than one equations that kind of work in the same system or have the same solutions, if that makes sense. So, really, we're talking about, I don't know, is this set to right yet? No, it doesn't look like it is. So, it's 2 spelled with a W in this sense, because I was going to spell it TOO, which would be wrong because I'm talking about the number 2. 2 or more linear equations. But the thing that these things have in common is that they're graphed on the same coordinate plane, right? And we're trying to find common solutions between them. And there's types of solutions. We have one solution, 2 solutions, and no solutions. One solution, infinite solutions, and no solution. So if I have 2 separate lines and I am graphing them on a coordinate plane, here's one of them. Ooh, that's a really straight line. I'm usually impressed with myself when I do that. Right? 2 separate lines for equations and they're graphed on a coordinate plane. When they intersect, that is the solution. That's where both of these, that's the one point where both of these things are true. So at intersecting lines, we have one solution. Can you guys think of an instance where there's 2 lines graphed on a plane that there would be no solutions? So if where they intersect is where our solutions are, where would they not have any solutions? Crickets. I hear crickets. Yeah, exactly, Linda. Parallel lines. Parallel lines never intersect, right? They go on forever and ever and they never cross, which means that if we have parallel lines graphed on a plane, let's see if I could draw something even close to parallel lines. Right? Pretend these lines are parallel, right? At no point will these ever cross, right? They're always going to be the same distance apart. So they're not going to have any solutions. The last one is infinite solutions. And really, the only time that happens is when a line is like a multiple of another line. And so they graph on top of each other. So when that happens, all of their points are solution. Every point on each line is a solution because it's just a multiple of the other line. So I can graph one and the other one's going to graph right on top of it. So everywhere it's true for one, it's going to be true for the other. And so those are your different types of solutions when we're talking about systems of equations. And currently we're just talking about with 2 different equations, but we'll move into the area where we're going to try and find solutions for 3 equations in a system. But for today, we're going to stick to the easier, softer way. Like I was even going to do the substitution part today, but I'm not. I'm just going to go and find the solutions by graphing, and that is all you guys will be working on today. We'll deal with the algebraic portion, the more algebraic portion later this week, because we want to ease into this week. I do. I have a little bit of a headache today. It was a long weekend. It was my kid's birthday. So that's how I lead into everything. Ask my 7th graders. When we have a problem like number 1, where we have y equals negative 5/3 x minus 6, and we have y equals negative 1/6 x plus 5, super easy to graph those equations because they're all in the slope-intercept form, right? So if I look at that first equation, let's see if I can make it really big to make it easier to graph. If I look at this first equation that we have here, and I want to graph that line, I know that my y-intercept for this equation is at -6. So I'm going to have a point. If it'll let me draw one, which clearly it doesn't want to do. I'm going to have a point on the y-axis at -6. I'm trying to draw it big enough so that you guys can see it. And then we can find the next point by looking at the slope, right? Which is negative 5/3. Now, when I have a negative slope, only the top or bottom has to be negative. I don't have 5 places to go down, so I'm going to count up 5 and then go over to the -3. So I'm going to take the 3 negative. So I'm going to go up 1, 2, 3, 4, 5, and then over to the -1, 2, 3. My printer just started like ghost printing right now. Like there's nobody else in this room, so it shouldn't be printing. 1, 2, 3, 4. So with those 2 points, I guess so. The thing is, some other classrooms can find my printer, like it'll come up as an OK printer for other teachers, and they just click on the wrong one, maybe. Or maybe Mr. Gormson is printing from a whole other room. Now pretend that's a straight line, right? That's what I'm going to do. I'm going to pretend. My old whiteboard had a ruler that I could use, but no. So that's the equation. That's the graph of the equation of the first line. The second line, we know that we have a point on the y-axis at 5. And then we have a slope of 1/6. Instead of going up, I'm going to go down 1 and over 6. Where's 6? Over here. Man, my pen keeps shutting off. I think it's because I'm hitting. There's buttons on my pen and I keep hitting them. They must have been reactivated. Down 1 over 6. Man, stop it. And I could do that forever. I could go down 1 and over another 6 somewhere over here, but it doesn't matter. Look, I moved the whole graph that time. My point was over here. All right. I'm not struggling. I'm not struggling at all today. I don't care what anyone says. I can make this pen work. So here's this one. I'm going to extend the green one. Can I? Absolutely. Goes on forever and ever. And so this intersecting point where they meet is our solution. What is it? I don't know. According to my paper, it's minus 6, 4. But according to my eyes, I can't really tell. Because as much as I made that giant, it's not all that giant. Let's look at another one. I'll do better this time. I'm going to do different color. We're going to do orange. We're going to make it bigger so that I could actually read the numbers. So y equals 5. Y equals 5 is just at 5. Dang it. We have a horizontal line, right? Anytime we had y equals anything, it was basically a line that went all the way across. Our next one is y equals 2x plus 7. So if I do that, I know I've got a point at 7, right? And then my slope is 2. I'm going to take my slope down. 1, 2 over 1 in the negative. If I'm going negative, I have to take them both negative. I could have gone up 1, 2 and over 1. Either one of those is okay. I went down because I knew the other line was, dude, there's no way I'm going to be able to draw this line straight. But what we found is that this right here, if I had drawn it properly, I'll just make the dot bigger so that the line actually goes through it, that the solution to this one would be negative 1, 5. Right? So that's all we have to do to find these solutions. We graph the lines. Where they intersect is going to be our solutions. And it's not always going to be this easy because they're not always going to be written in slope-intercept form. Right? I think I said it in delta mass so that your first 5 were in slope-intercept form. And then the next 3 you had to like manipulate to get into slope-intercept form. So if we look at number 3, make the graph even bigger. We're going to make it even bigger. We have a little bit of work to do before we can graph these problems, right? We have 6x minus 5y equals 45. So I'm going to have to redo these problems. So I'm going to go 6x minus 5y equals negative 45. And I am going to solve this for y. I'm going to put it into slope-intercept form. I'm going to start by subtracting that 6x from both sides, where I get negative 5y equals minus 6x minus 45. And then I'm going to divide everything by negative 5. And when I say everything, I mean I'm dividing this by negative 5 and I'm dividing this by negative 5, right? This becomes y equals 6 over 5x. Negative 45 over negative 5 is positive 9. And so now we have it in that form where we could graph it. I know that I have a point at 9, right? I have a slope of 6/5. I can take that negative and it's still a positive slope. So I could go down 1, 2, 3, 4, 5, 6 and over negative 1, 2, 3, 4, 5. And I have to put my freaking pen on again because that seems to be the consensus every time I do something. The pen wants to turn off. And so now I have my 2 points and I can connect the dots, hopefully in a not straight line, because that's what I was really going for, a line that is so not straight it doesn't even look like a line. And then we have to do the next line, right? We're going to have to do it again for the next problem. We're going to have to see what we have there. So now I have 2x plus 2y equals -4. And we're going to do the same exact thing. We're going to solve it for y. So we're going to subtract the 2x from each side, and we will have 2y equals -2x minus 4. We're going to divide everything by 2, and I do mean everything. And we get y equals, well, that's -x, right? 2 over 2 is 1, so that just gives me -x minus 2. And so we know that right here on the y-axis, we have a point. Negative x means that my slope equals -1, right? Or -1 over 1. Which means that I could go up 1 and -1, or I could go down 1 and +1, and I could do it forever, right? Up 1 over, up 1 over, up 1 over. Why do I keep doing it? Because I know, well, I know that I'm going to move the entire thing. And when I graph this line, it is going to join right here, right? This will be our solution. Our intersection will be at -6, 3. And so when we're looking for the solution of that line, we know that it is -6. Sorry, -3, right? It's negative in both directions. Actually, it's +3. I don't know. I need to wake up. That y is positive. We're not below the x-axis. Dude, did you see that? I made the whole worksheet disappear. Crazy. How do I get it back? I don't know. How do I get it back? Do you have to bring it back in? Yeah. I don't know if I'm going to buy this again next year. I spent $85 on this whiteboard. And it's not my favorite so far. And all my stuff just disappeared. If I look at number 4, we'll just move on to the next one. I do better in Kami, right? Like, because everything stays there with Kami. When I look at this problem, I have one of my equations in that slope-intercept form, right? So that bottom equation is going to be pretty easy to graph, but that top equation we're going to have to do a little work on. We are going to have to put that into the slope-intercept form. 3x plus 6y equals -12. So I'm going to just subtract that 3x from both sides, -3x, and get 6y equals -3x minus 12. And then we divide everything by 6. And we get y equals, well, 3/6 is -1/2 x. 12 divided by 6 is just 2. And so now we have it in that form that we want. So if we want to graph this line, we're going to go with the point on at -2. And then we can count out the slope. We can go down 1, +2, or we could go up 1, -2. Doesn't matter, right? We just know that it's going to follow that path forever and ever. And then when we look at the next line, the bottom line, when we go to find the solutions on that one, we go, okay, well, we have a point at -5 on the y-axis. That's hard to see with that color. And our slope is also -1/2. What do we know about things that have the exact same slope? Does anyone remember? Yes, Dylan. Parallel lines. If the slopes have the same, if the slopes are equal, then we have a parallel line. These two lines are never going to intersect. So we can just say no solution. Fair enough. I was hoping to find one that had infinite solutions. Oh, I do have one that has infinite solutions. So I'm going to do one more, although I kind of gave it away, right? I already told you that it's going to have infinite solutions. What was that? How did I do that? What? Did you see that? I wish I knew how to do that. That made a straight line. I can't make a straight line. That made a straight line. So, first problem that we're looking at, fairly easy. If you look at that bottom problem, it's also almost in, both of these are almost in slope intercept form, right? If you look at the first problem, the only thing that's keeping it from being in slope intercept form is that we have that negative in front of the y, which means we're going to have to divide or multiply everything by -1. So I am going to switch to orange because I didn't like the way the blue came up on the. So if I have -y equals -x minus 6, I just have to divide everything or multiply everything by -1. And the reason for that is that I don't care what -y equals. I care what y equals. So all multiplying or dividing everything by -1 does is change the sign of everything. So this becomes x plus 6. And then I could go and graph it really easily, right? At 6, I'm going to have my point. My slope, because there's nothing in front of the x, is just 1 over 1. And so, every 1 over, like I'd have a point, right? And this would go, I really need to figure out how I made that straight line because that was, so pretend that that is a straight line and not two weird lines. And then we'll go look at the next problem. The next problem is, like I said, almost in slope intercept because we have 3y equals something, right? I have 3y equals 3x plus 18, right? All I did was switch where the 3y and the 3x plus 18 are so that we could kind of see it in the form we're used to. They're equal, so it doesn't matter which one I put on which side. And then we're just going to divide everything by 3. And you'll see that we get y equals x, 18 divided by 3 is plus 6. So when I reduce that down and I put it in the form, they're the same equation, which means that this one would graph right on top of the other one. Now pretend that that's what's happening there, that they're not like these two sketchy lines that I just drew, and that they sat literally on top of each other, which means that everything that's a solution for one is going to be a solution for the other, because clearly they're the same line, right? They have the exact same graph. And so our solutions are infinite. Anything that I plug in for x on one is going to give me the same y on the other. So we have infinite solutions. So hopefully that gave you an example of each of them. When you do it in Delta Math, we're just going to do a level 1 problem. Oh no, that's an inequality. We don't want that. We want an equation. Where are my systems of equations? There. So when we have a problem, we want to put it in graphically. We're going to plot two different lines. Like one we know is going to be at -7, right? That'll be our first line. And then we're going to use our slope. So if I go +3, 1, 2, 3, I have to go -1. And there's the graph of my first line. So my next line we know is going to start at -3, and we have a slope of 1, so 1/1. And I've plotted both of those, and I can see that my solution is right here at -1, -4, and I'm going to plug that in. I need to put in the parentheses. -1, comma, -4. Always put your x in first. And that's all you have to do. So you just graph both lines wherever they intersect. It's a lot easier when you're doing it on a graph like this and you're not having to draw and figure out where the lines meet. But that's how they'll all be. Some of them, of course, you're going to get in this level 2 where you're going to have to, you're not supposed to be getting more than one inequality in this. I'll check that out before I open it up. I might get rid of those level 2s. Because some of them you're supposed to put in order, but it looks like I might have to go in and look at that second level because it looks like it's giving us harder problems than you guys are ready for. Oh, that one looks okay. So if you look at this second problem here, x minus y equals 8, you're going to have to put that in the slope-intercept form so you know how to graph it. That's the only difference on these level 2s. At least it's supposed to be the only difference on these level 2s. All right, maybe I clicked on a wrong thing before because it looks like we're in check here. I'm like, we're not supposed to be doing 3 equations yet. That's not for quite a while yet. Any questions about any of it?